Join us to the Midwestern mountains of Nepal. We are heading to Dailek district, a remote area with limited access to potable water.
पानीको सरसफाइको पानीको शुद्धिकरण नभएर अनि पर्सनल हाइजिनको कमीले गर्दा.
How can current research and local knowledge join forces to reduce water-borne diseases and related mortality rates? We evaluate how innovative approaches help to implement water safety planning in remote alpine regions. We pilot solutions to overcome topography-inherent hurdles and the lack of basic infrastructure. Airwag's Water Supply and Treatment Group partners with local communities and Helvetas Swiss Intercooperation, an NGO with more than 20 years of experience in the region's water sector. Only in recent years, households are gaining access to piped water, supplied at communal or private tap stands. This has reduced daily walking distances for water collection tremendously. But is this water fit for drinking? In a recent study, Airwag has found fecal contamination in 4 out of 5 taps. We return to review the schemes, combining simple sanitary inspections and scientific experiments. We followed the course of the water, starting at the spring intake. From the spring intake, the water is piped to storage reservoirs, where we installed data loggers for key water parameters. We systematically followed the pipeline to identify potential pathways for contamination influx along housing infrastructure and all the way to the tap stand. While the sanitary inspections of tap stands turned into an interactive event, the installed flow and pressure meters initiate discussions on management approaches. To verify the potability of the tap water, laboratory assessments are inevitable. Thus, we had to modify laboratory procedures to reduce consumables, energy and training. Based on a solar voltaic array, we developed a low-watt incubator to grow bacteria cultures at low outside temperature conditions. Pristine alpine settings may suggest safe spring water, but as we now know, this is a risky assumption. To identify hotspots for contamination, sanitary inspections proved to be an excellent tool. If they are combined with scientific experiments like salt tracer testing, they can help visualize the potential pathways of hazards into the water supply system. The systematic review led to the redesign of the scheme's spring protection, as it was identified as the most risky missing barrier to prevent hazards from entering the system. The gained in-depth understanding now serves as a basis for generic water safety plans and the development of recommendations for this type of water supply system.